Hi, welcome back to our work sampling video series. We're going to get started on an example problem, and the information is shown on the slide in front of you here. So we know when we set up a work sampling study, we need to have the type of subject that we're looking at, and in this case it's machines. And we talked about one of the advantages of work sampling is when we have a grouping of machines or grouping of the type of people we're looking at, work sampling is a good way to capture information across them all. So in this case we have 10 machines, and we are going to, we have a total of 500 observations, and I'll talk about that in a little bit. We've taken at random times during a 1-week period. Okay, so we talked about the importance of sampling over a time period that we could capture all of the activity that might be happening within that subject, in this case the machines, and how many observations to take gives us a degree of accuracy, and we'll show that calculation later. So this one decided on 500. I told you for the purposes of the study that you're going to do 20 to 30 will work out. That's because I know of the time constraints, it's going to be unlikely to get something as high as 500, but we'll talk about that more later. So we know that our subject are machines. We have our categories identified here. So we have a category of being set up, the machines being set up, the machines running production, or the machines being idle. And so these were all taken again at random times across the week, and there must have been a place on the floor where they could take an instantaneous observation and be able to see, like, okay, I see one machine is being set up, 5 are running production, and 4 are idle. And that would have been the data collected for one observation. As an example. As it turns out, for these total 500 observations, 75 of the observations the machine was being set up, 300 it was running production, and 125 the machine was idle. So we've gone through, we had set up the study with our subject being machines, our categories being listed over here. We determined our study logistics and actually collected the data over a 1-week time period. And so one of the questions that is important to know within a work sampling study is, what is the proportion? And we call the proportion the p-value for each category. And then we might just want to extend this. I just think it's interesting data point and something to put in perspective is how many hours per week did an average machine spend in each category. So to get the p-value or the proportion, all we do is take the number of observations in the category and divide it by the total, and that is the proportion of time that the machine is spent in that particular category. So let's go and look at the next page. We have the information here. So as I said, proportions are determined by taking the number of observations for that category and dividing it for the total number of observations across the study. So being set up, the proportion or p-value 75 divided by 500 is 15%. For running production, there was 300 observations of the 500 that were running production, that's 60%, and the machine was idle 125 of the 500 observations, 25%, and that totals up to 100%. And then again, you don't have to do this for all the studies. I just think it's another interesting perspective to be able to put it in of the hours per week, how many hours is spent in each category. So here we just take the proportion, 15% of the time the machine's being set up, multiply that by 40 hours in a week, and that would say 6 hours a week on average a machine is being set up. Follow the same calculation, 24 hours a week the machine is running, a particular machine is running production, and 10 hours a week a particular machine is idle. So as a production supervisor of the operation, number one, would you believe the data? Why or why not? So again, we had 500 observations over a 1-week time period, and this is what we came up with. So as the supervisor of the operation, would you believe that? Why or why not? And how could you work with the supervisor ahead of time, possibly, to make sure that there is going to be buy-in and belief in what the data is telling us? And then also, what action are you going to take as a result of this information? So you can see here that only 60% of our time is spent in value added, and then we have 40% in non-value added. Maybe setup is necessary because we have to change parts, but machine idle, that's probably not necessary. And so what actions would you take as a result of the information that you have here? So why don't you think about that for a minute, and you can bring it and we'll discuss it more in class, answering these two questions here. Okay, but for me, I'm going to go to the next page for my example solution. I'm going to look at the percent of time that the machine is idle. And so I would look at, I see that total observations are 500. There's 125 of those observations the machine is idle, and so there's my 25%. So this is just a repeat of what happened, the data that we showed in the analysis portion on the prior slide. So now we get into the statistical analysis of that. And so accuracy results. So we can state, I don't know if I like the word accuracy here. Let's just say results. We can state that we have captured 95% of the population. I'll explain this 95% confidence limit in a minute, but 95%, 95.4 to be exact, 95% of the population is going to be within 21.1% and 28.9%. So what that means is if we looked at this process for 7 days a week, 24 hours a day, over 100 years, we're confident that we have the actual mean of the percent idle time is between 21 and 29%. I'm rounding 21 and 29%, captures 95% of the population. And so that comes from this normal curve distribution up here. Now I know not all of you may have had statistics yet, but this is a normal curve, normal bell curve, and then this signifies 1 standard deviation, 2 standard deviations, 3 standard deviations below the mean, 1 standard deviation, 2 standard deviation, 3 standard deviations above the mean. So if we capture 68% of this population, that's going to be within 1 standard deviation of the mean. To capture 95% of the population, we need to go 2 standard deviations out. And to capture 99.7% of the population, we go 3 standard deviations out. So when we talk about these confidence intervals, what we're saying is what percent of the population have we captured to be sure that the true mean is within it. And so we're going to, as a standard, say 95.4, 95% of the data, 2 standard deviations away from the mean is what we're going to be looking at. We want to be sure that the true mean of the percent idle time is within this 95% band of the population parameters here. And that just happens to be 2 standard deviations. For those of you who are statistics savvy, you know that in reality, if you go and look at a normal table, the value is actually 1.96. We're just simplifying it in our case and using 2, and you'll see that in some calculations we do in the next video on how we came up with this 21 to 28%. Okay, and then I haven't shown you the accuracy of the study yet. We need to be able to calculate that based on the data that's provided. This confidence level, the confidence limit, 95.4%, we decide that. So we decide, do we want to capture, be sure that we've captured 68% of the population, be sure we captured 95% of the population, or be sure we've captured 99.7. So we determine that going into the study. And in most all cases, all the examples we're going to do, it's going to be 95% or 2 standard deviations. So we determine that going into it. However, to determine the accuracy, so how much error do we have in the study, that is something that is determined from the data. And again, we'll go over that calculation regarding this machine idle time, so this one category of the 3 categories that were listed in the second part of this problem video here. And then also, maybe we think this interval, this confidence interval is too wide, 21 to 29, so 7 percentage points, and the operations controller, or the VP of operations, some head honcho, wants to know how many more observations are required to reach 99% accuracy. So again, we don't know what the accuracy is, but what if we want to reach 99% accuracy? So number 1, we need to figure out what is the accuracy of the study. And then number 2, if it's not at 99%, then how many more observations, more than 500, do we need to take in order to reach that level of accuracy? Okay, so we're going to go into the next video to actually go through the calculations of how we determine these confidence limits, how to calculate the actual accuracy of the study, and how to know how to calculate how many observations are needed in order to reach this 99% accuracy. And then we'll also talk about conclusions and recommendations. So that's one thing to go through, to collect the data and go through the math, the arithmetic to determine what this information is, but then what do we want to do with it? What conclusions are we going to draw? What next steps, what recommendations are we going to make to go reduce idle time, for example, or to increase the accuracy of the study? Okay, so we'll follow through on that in the next video. Thank you.